Hello all, and I'm sorry for the delayed video. I'm not going to do a ton of talking today. I'm going to let you go and watch a couple videos on the derivations. One of the derivations that we spent a lot of time in class for the formula for the area of a circle, and one that provides a second geometric derivation. And I think that those give a really nice overview of what we did and how you can see the multiple ways that we can develop an equation to use to find the area of a circle. To start with our practice check from yesterday, we're looking for an estimate for the area of a circle, not the exact area of the circle. And we have a couple tools to help us here. We have the grid that's underneath all of these large shapes, and we can use those to talk about square units. Any of the small squares would be a square unit, and that would be 1 unit of measurement. It covers 1 square, for example. And then on top of this circle, we have 2 squares that are overlaid. We have a slanted square that's inside the circle, and we have a large square that is around the entire circle. We can use the area of those 2 squares to help talk about the area of the circle. If I begin with the slanted square, I want to look at how many square units are inside that slanted square. I notice that there are 12 whole squares inside of it, and then that there are also 12 half squares. We have what look like triangles as the slanted square cut across some square units. So 12 half squares would be 6 whole squares if you put them together. They combine to make 6. If I do 12 plus 6, I'm going to have 18 square units inside of that slanted square. Then if I look at the large outer square, I notice that it is a 6 by 6 square. If I then am going to do the area of that, 6 rows and 6 columns, an array of 6 times 6 will give me 36 square units, and that tells me then that the area of that outer square would be 36 square units. I know that the circle is bigger than the slanted square because the slanted square is inside of it, and it's smaller than the outer square because it is inside of the outer square. That means its area must be in between the area of those 2 figures. It then has to be more than 18 square units, the slanted square, and less than 36 square units, the outer square. And that gives me an explanation of why the area of the circle is more than 18 square units and less than 36 square units. Moving into a formal derivation of an equation that you could use that would be precise, check out tinyurl.com/rectangle derivation if you want to look at what we did in class yesterday, where we cut the circle up and made parallelograms and then ended up making a rectangle. And if you're interested in seeing a different way of deriving that formula, one that uses a triangle and peels it open, or peels the circle open, check out tinyurl.com/triangle derivation. I think that it's cool to see the ways in which these 2 derivations are related to each other, and you might find one that makes more sense to you based off of if you prefer working with a rectangle or if you prefer working with a triangle.